Hello everyone, welcome to Shiwam's classes. In today's lecture, we are going to discuss problem number 17, 18 and 19 of exercise 3.3 chapter 3 of class 11 mathematics. So we have already discussed problem number 1 to 16 in previous videos. So you can go ahead and watch those videos and have a look at the solution. So we'll start today's discussion with problem number 17. So as usual, before starting the discussion, we'll try to understand again the concepts behind the problems and try to work out the solution. The first problem is talking about some expression on the left hand side, which is sin 5x plus sin 3x divided by cos 5x plus cos 3x. So we got to prove it to be equal to tan 4x. So when you look at the expression on the left hand side, you just look at the numbers first, and then you can see that there is a number 5x, there is a number 3x, right? And when you sum it up and divide it by 2, you will get, once you sum it up, you will get 8x, right? When you sum it up, and then when you divide it by 2, you will get 4x, right? So it is looking like it is some sort of a formula wherein you have to use c plus d by 2. And we already know that there are two formulas. One is sin c plus sin d, and which is equal to 2 of sin c plus d by 2 into cos of c minus d by 2. This is first formula. And the second formula on the cos side is cos c plus cos d equals to 2 times cos of c plus d by 2 into cos of c minus d by 2, right? So these are two formulas, and by looking at the expression and knowing that the numbers are given in such a way that it will reduce to 4x. So we'll start with the problem now. So let's start with the problem first. So this is my LHS. When you look at my LHS, it is sin 5x plus sin 3x divided by cos 5x plus cos 3x. Right? Now, when you try to work out using the formula, this will be 2 of sin of c plus d by 2. Yeah, this means 5x plus 3x by 2 into cos of 5x minus 3x by 2 divided by 2 of cos of c plus d by 2, which is 5x plus 3x by 2 into cos of 5x minus 3x by 2. So 2 will cancel out, and this is also cos 5x minus 3x by 2. This is also cos 5x minus 3x by 2. So this all will also cancel out, and then the numerator will become sin of, this is 5x plus 3x by 2. This is 8x by 2, which is nothing but 4x, and divided by cos of 5x plus 3x by 2, which is nothing but again 8x by 2, which is 4x. And we know that sin 4x upon cos 4x is nothing but tan of 4x, which is what we had to prove on the right hand side. So this is a straightforward application of sin c plus d, sin c plus sin d formula and cos c plus cos d formula. So this is how you have to apply. You look at the left hand side, try to see what is the number given on the left hand side and what's the number on the right hand side, and then start working out the problem. So let's go to the next problem, problem number 18. Here too you can see that the expression is sin x minus sin y and divided by cos x plus cos y. So as we were doing in the earlier example, we got to know these formulas all right. Sin c minus sin d. What would be my sin c minus sin d? It would be nothing but 2 of cos. Here sin changes to cos if there is a negative over here. This is how you remember. If there is a negative sign over here, the sign will change to cos, and that will be c plus d by 2. So whatever c plus d by 2, c and d plus, so whatever with expression in summation will have cos cos term to it, and sine will be having c minus d by 2. Similarly, cos c plus cos d we have already done in the previous example, which is nothing but 2 of cos c plus d by 2 into cos of c minus d by 2. Alright, so you have to just use the formula. Let's use the formula here. So sin x minus sin y divided by cos x plus cos y. Now sin x minus sin y is 2 of cos of x minus x plus y by 2 into sin of x minus y by 2. This is what we have done over here. Sin c minus sin d. This is the formula. And now this is 2 of cos of x plus y by 2 into cos of x minus y by 2. Now by this 2 gets cancelled out, cos gets cancelled out. So we are left with sin of x minus y by 2 divided by cos of x minus y by 2, which is nothing but tan of x minus y by 2, because the theta inside it is same x minus y by 2, here it is also x minus y by 2. So which is nothing but the RHS which you had to do. So these are again straightforward application of formula, and you could see that on the right hand side the expression is given in such a way that while you try to solve on the left hand side you will be reduced with the same thing. Alright, so in such application or such question, you see that whatever is the complicated question or the equation, you try to solve it to reduce it to the simpler one. And in this case our left hand side was pretty complicated and on the right hand side it was very simple, right? So this is what we had to start with. We had to start with the complicated part and try to reduce it to much more manageable form. Alright, so let's move on to the next problem, which is problem number 19. And here again, it's again application of the formula. It's sin c plus sin d divided by cos c plus cos d. And as you could see over here as well, there is 1x and then there is a 3x. So when you add it and divide it by 2, so that term will remain and rest of the terms will cancel out. So let's use the formula in a straightforward manner and get the result out here. Sin x plus sin 3x divided by cos x plus cos 3x. So this is the formula for sin c plus sin d. So I'll get 2 into sin c plus d by 2, which is x plus 3x by 2 into cos of x minus 3x by 2 and divided by 2 of cos of x plus 3x by 2 into cos of x minus 3x by 2. So my 2 cancels out, cos x minus 3x by 2, cos x minus 3x by 2 cancels out. So we are left with sin of x plus 3x is 4x, 4x divided by 2 is 2x, and this same way x plus 3x is 4x divided by 2 is 2x. This is what 2x. So sin 2x upon cos 2x is nothing but tan 2x. Right? So here as well we use the formula sin c plus sin d equals to nothing but 2 of sin c plus d by 2 into cos of c plus d by 2, and cos of c plus cos of d equals to 2 of cos of c plus d by 2 into cos of c minus d by 2. Alright, so when we look at such expressions, we have to be aware that this is gonna be the simplification of the equation and to reduce it to the much more simpler form on the right hand side. You should not get confused by saying 3x and try to use the formula of that. You could actually do that as well. There is nothing wrong, but it's much easier to use it this way. So alternative way to do it is, if you remember the formula of sin 3x, right? If you know the formula of sin 3x, you could directly put the value over here and then try to solve it as well. Then in that case, what you got to do is you'll have to solve the left hand side as well as on the right hand side.